Greetings, people. Let's have a look at this concept, which is a very interesting concept and an easy one at the same time. I do believe that you will get it right. We're looking at NR, which is the nutritive ratio. When we check at the nutritive ratio, there are a few things that I want you and me to focus on. One, we must look at the guidelines, what we need to check here. One, we must be able to define the NR, the nutritive ratio. We will check what is the definition of it. Two, we must then be able to calculate the NR. We will use a formula to calculate the NR. And I will give you two formulas. It's very important to know when do I use the first formula and when do I use the second formula. After calculating the NR, we must then interpret the NR. It's also important to know the interpretations of the NR, because at this point of time, what they do, they don't normally say calculate the NR. You find that they give you a table with the NR calculated. Then they ask you questions based on the answer that you are given or based on the calculation that they made for you. So I want you to focus more when we talk about the interpretation of the NR. We will categorize the NRs into two. We will have a wider NR and a narrow NR. So it's very important to know what is the function of the wide NR and what is the function of the narrow NR, whereby we will be describing the purpose or the aim of the NR in an animal feed. Let's quickly have a look at the definition. We say NR is an indicator of the protein content of a feed. We are looking at the amount of proteins in a feed. We look whether do we have more proteins in that feed or less proteins in that feed. Once we understand that we have more proteins, then that will assist us to know what is the role or the function of this feed. Once we understand that we have less proteins, whereby we will say once we have less proteins, we will have more carbohydrates and lipids. Then we will understand that, okay, fine, this feed is responsible for which purposes. Let's look at the formula for calculating NR. I said to you, I will give you two formulas. I kindly request you to understand these formulas and know the function, and know when to use each of these two formulas. We have the first one, which says NR is equal to 1 is to TDN minus digestible proteins, which is DP, divided by DP. Let's look at it. It's NR is equal to 1 is to TDN, which is total digestible nutrients, minus DP, which is digestible proteins, divided by DP. Please take note of this part, my people. Always never forget this one. Some of you end up writing the TDN minus DP divided by DP. Always recall or reminisce to write the 1. 1 is to TDN minus DP divided by DP. Okay, fine. Then you have the second formula. The second formula says NR is equal to 1 is to digestible non-nitrogen substances divided by DP. So once you say DNNS, go DP, you just say divide by DP. You will understand what let DNNS learner see tatago. Let me just explain it to you now. If you have a pen, just take this one down. When we check this one, the TDN, it simply means all the nutrients. TDN, we are talking about all nutrients that are digestible. That's what we talk about. So we include your carbohydrates, we include your lipids, we include your minerals, we include vitamins, we also include proteins. So we're looking at all the nutrients that are digestible, So that is your TDN, total. Then now we are on what? On DP. On DP, we only focus on proteins. So here we look at proteins only. That's why we just say digestible proteins. So sometimes, let me highlight this one. Sometimes they may not give you the exact TDN. Take note of this one. Sometimes they may not give you the exact TDN. But what they can do, they can give you percents for carbohydrates, percent for lipids, percent for minerals, vitamins, and proteins. Then they say, please get the TDN or calculate the NR, but you don't have the TDN. So what I want you to do, you must add the figure for carbohydrates, the figure for lipids, the figure for minerals, the figure for vitamins and proteins. You add all of them together. Then they will give you what? They will give you the TDN. Okay. Now we have this DNNS. What does this DNN stands for? It's written digestible non-nitrogen substances. I will just summarize this one. When we talk about these digestible non-nitrogenous substances, we are talking about the nutrients that are digestible, excluding or except proteins. So these are all nutrients. Except what? Or excluding what? Excluding proteins. You will see a formula for calculating this one now. So we say when you talk about the DNNS, these are the nutrients without nitrogen. So the nutrients without nitrogen are the carbohydrates, the lipids, but then we must remove what? Proteins. I hope you get this one. I said to you, my people, it's very important to know which formula am I using. Then I said here, if in your question you are only given DNNS and the DP, you must use the second formula. If you are given DNNS and DP, you use the second formula. But in your formula, you are given the TDN together with the DP. Then you must use the first formula. If none of these are given, remember that I said you must add the carbohydrates, lipids, proteins, minerals, and vitamins, whatever that is there in that table or that data that will be given. Let us look at the formula to calculate the DNNS. Esite, these are all the nutrients, excluding what? Excluding proteins. Let's look at the formula. We have this formula. All the nutrients excluding what? Proteins. So to calculate the DNNS, we will say total digestible nutrients minus digestible proteins. We say the TDN minus what? Minus the proteins or the DP. Maybe we'll get to some of this. Let's look at this one. Let's now try to practice using the formula. We are given this table, my people. Feed A, you have a TDN of 80%. Feed and the DP of 10%. Then we are requested to calculate the NR. Feed B, we are given a TDN of 70% and a DP of 12%. We are requested to calculate the NR. As you see that there is no NR there. Let's start with feed A. This is my feed A. This is my feed B because it's now hidden. When we look at this, you are given the TDN and the DP. So it means we are using which formula? The first formula, NOTDN. What does the formula say? It says NR is equal to 1 is to TDN minus dP. Divide by what? Divide by dP. We're calculating for feed A. Now you have the formula. TDN, 1 is to TDN minus dP. Divide by what? dP. Let's substitute. For TDN, it's 80% minus dP, which is 10%, divide by dP, which is 10%. Remember, you don't forget the 1 here. Let's simplify, my people. Let's use this smaller space that we have. 1 is to, you say 80, you start by solving this one. 80 minus 10, you get what? 70. Divide by 10. And it. Let's again simplify. This will be my final answer. Then you say 70 divided by 10, you punch your calculator. When you punch your calculator, you will get what? You will get 7. What does this mean? It means the NR of feed A is 1 is to 7. We started by choosing the formula. We substituted. We simplified. Then we punched our calculator. We came up with 1 is to 7. Take note of this one. We'll come back to it. So we can conclude and say here, the correct ratio is 1 is to 7. I hope my dot there are visible. Let us calculate for feed B. Let's check how can we calculate for feed B. Feed B, you are given a TDN. You are also given a dP. We use which formula? The first formula. What does it say? It says NR is equal to 1 is to TDN minus dP divided by dP. Sorry with this one. This one is not supposed to be here. Let us substitute now. What is our TDN? Our TDN is what? 70. What is our dP? Our dP is what? It's 12. Divide by what? 12. Never forget the 1 here. You say 70 minus 12. You punch your calculator. What do you get? You get 58. We have our 1 here. Divide by what? 12. You punch your calculator. 58 divided by 12. You have the 1 again here. What do you get? You get 4.8, which can be rounded off to 1 is to 5. So that's how simple it is for you to calculate the NR. Now I'm getting to the most interesting part and the most important part, which is the interpretation of what? Of the NR. Let us check the interpretation of the NR. I hope you mastered the calculations here. When we check the interpretation, I said to you, my people, the ratios are categorized into 2. We have a narrow ratio and a wide ratio. I want you to understand the differences between these 2 ratios. When we look at the narrow ratio, I will start with the narrow ratio. A narrow ratio, we are saying it is an NR that is 1 is to 6 or less. Once you are to 1 is to 6 downwards, we then say it's a narrow ratio. Let us check what kind of nutrients is carried by this narrow ratio. A narrow ratio has more proteins but less carbohydrates. Has more proteins but less carbohydrates. Then, if we say it has more proteins but less carbohydrates, let's try to recall the functions of proteins back in grade 10 and from the components of feeds. One of the functions of proteins is that it is responsible for growth and also responsible for what? For production. So the narrow ratio will be responsible for growth and also be responsible for what? For production. And remember, we say the ratio is narrow if and only if it is 1:6 downwards. 1:6, 1:5, 1:4, 1:3, 1:2, 1:1. We will say that one is what? It's a narrow ratio. And what kind of nutrients are more in that ratio? It is what? It is your proteins. And since there are more proteins, it means that feed will be responsible for growth and production, which is one of the functions of what? Of the proteins. Let us look at what? Let us look at the wider ratio. When we look at the wider ratio, I also say the NR for milk production is 1:4. Let's look at the wider ratio. The wider ratio was saying it starts from 1:7 or more. Once it is 1:7 upwards, we'll say that the ratio is wide. What kind of nutrients are more in that ratio? Once it is a wider ratio or 1:7 or more, it simply means that it has more carbohydrates and lipids. You will recall the role of the carbohydrates and lipids. You will say it's for fattening the animals. And again, it can also maintain the animal or the body mass of the animal. So we'll also say it's for maintenance. So let us look at the function or the responsibility of this feed that has a wider ratio, which is more than 1:7. We will say this feed, it is good for maintenance. What I did here, I tried to categorize this one, which ratio specifically is good for maintenance. The one that will be good for maintenance, it will be your 1:8, and it will also be your 1:10. But sometimes we just say a wider ratio is good for maintenance and fattening without being specific on which ratio specifically is for maintenance and which ratio specifically is for fattening. So we are saying here we have two types of ratios. The narrow one, which is 1:6 square pounds, and the wider one, which is 1:7 GPa. The narrow one, kusho ukuthi nama proteins amaningi. So it simply means that in 6 nutrients that you have, one will be what? Proteins. So we have more proteins in that one. Then we say if we have more proteins, we'll have less carbohydrates. I don't want to focus more on that one. Then sesithi yenzani ke i-ratio enama proteins amaningi izoba good for growth, phinde be good for production. Yenzani i-ratio enama carbohydrates amaningi, which is the wider one, 1:7 or more. Izoba good for maintenance, phinde futhi ibe good for what? For fattening. Now you understand ukuthi sina two ratios, ne? One is good for maintenance and fattening, which is the wider, and one is good for growth and production, which is what? Which is the narrow one. Let me go back a little bit. Allow me to go back a little bit. Let's look at this information. Let's look at this table. In this table, we did our calculation. If you are doing the calculation with me, we did our calculation and said feed 1, it's 1:7. Feed 2, it's 1:5. Remember that we got 1:4.8, then we rounded it off. Now let's categorize these feeds. Let us categorize these things. This one, it is 1:7 or more upwards. So it means if it is 1:7 upwards, it means it is a wider ratio. This one, it's what? It's 1:5. So it means it falls under 1:6 downwards. So this means this one is a narrow ratio. What nutrients are more in the wider ratio? We will say we have more carbohydrates and what? And lipids. Then our proteins, they are less. It is responsible for what? Since we have more carbohydrates and lipids, it means it is responsible for maintenance and also fattening. What about the narrow one? This one, it will have more proteins and less carbohydrates. Once it has more proteins, so it will be good for what? It will be responsible whether for growth or else what? Production. I want you to understand it in this matter. You must know how to calculate it. You must know how to interpret it. That is the most important thing. Let me hold it here for now. I will come with other examples which will be in a form of what? Of questions which we will do together in a presentation. Let me stop here for now.